Hey, how you guys doing? I'd say it's good to see you, but I don't see you. And if I could, I'd get really worried. Anyway, topic 1.07, using units to solve problems. Now, when we did the last topic, how to do algebra, remember I said about 50% of the math is going to involve actually using formulas of one kind or another. So you rearrange, you substitute, and you solve. Well, the other half of the math you're going to be doing involves converting from one kind of unit to another kind of unit, like grams to moles, or from liters to moles, or moles is actually going to be a large part of it. What is a mole? It's a quantity of substance. Uh, but more about that later. All right. So here's how you do it. Problem solving strategy, whenever you're doing conversions, is very simple. What you do is you identify what's given and what the target is. The given is going to have some kind of number and a unit. And the target will just say, well, how much of this and a unit. Write down what the given is, including the units. The given always has to go first. Always, 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 always. The only exception is never. Multiply or divide the given by whatever conversion factor will cancel out your given units and leave you with your target units. And you're going to use the units, use the units to decide whether to multiply or divide. And then record your target to the correct number of significant figures, including units. So, for example, how many minutes are there in 2.3 hours? Well, is there a conversion factor that can convert minutes into hours? Well, you may know that there are 60 minutes in an hour. Notice how minutes is on top and hours is on the bottom. I mean, it really wouldn't make any sense to say there are 60 hours in a minute. I mean, yeah, a minute can seem to take forever, but 60 hours? No. So the smaller unit always goes on the top. Think of it like oil and water, right? The oil is lighter, so it floats to the top, and the water is heavier, so it sinks to the bottom. So the smaller unit will float to the top, the numerator, and the bigger unit will sink to the bottom into the denominator. 60 minutes per hour. Now, how do we convert? Well, the first thing we want to do is write down our given, and our given is 2.3 hours. Now, in order to convert to minutes, we write down our conversion factor, 60 minutes per hour. Now, how do we cancel out hours to get minutes? Do we multiply or divide? That is the decision that is going to be the most important to make. Now, notice in our given, hours is in the numerator. It's really hours over 1. And in our conversion factor, hours is in the denominator. So numerator, denominator. How do we cancel that out? Well, we multiply. And by multiplying, hours will cancel and leave us with 138 minutes, which makes sense, doesn't it? Because 2.3 hours is a little more than, well, 2 hours is 120 minutes. So 2.3 hours should be a little bit more than that. So if you divided, well, you'd get a lot less than an hour, and it wouldn't make any sense. This is going to make up about 50% of the kinds of math you're going to have to do. This is it. This is all there is. It's really easy. Then, of course, we have to round our answer off. And we may look at this and say, well, there's 2 sig figs here and there's 1 sig fig here. However, the conversion factor is not a measurement, so sig figs don't apply. You convert your given to the target. The number of significant figures in your given will be the same number of significant figures in your target. And since we had 2 significant figures in our given, we round off our target to 2 significant figures. I went a little fast on that. 1, 2. This 8 rounds this to 1, 4. And then you put a placeholding 0 in to keep the number the same size. 138 rounds to 140. Okay. How many feet are there in 32 and 34.3 inches? So we're given 34.3 inches. Our target is feet. And we know there's a conversion factor to get us from inches to feet, right? I mean, there's 12 inches per foot. There aren't 12 feet per inch. That would be ridiculous. Once again, the smaller unit rises to the top and the heavier, bigger unit sinks to the bottom. So when we do our conversion, we always put the given first, then the conversion factor, Then either multiplication or division to cancel out inches and be left with feet. Well, this time, the unit we're trying to cancel out is in the numerator. So how do we cancel it out if the unit we're looking to cancel out is in the numerator? We divide. And by dividing, inches will cancel and leave us with feet. And when we do the division, we get, wow. So I know I have 2 feet. What would an extra 0.8 look like? Like extra toes, like sticking out from the sides of my feet? Oh, that'd be weird. Anyway, let's round this off with significant figures. 12 is a conversion factor, not a measurement, so sig figs don't apply. So we look to our original given. 3 significant figures, so we need 3 significant figures in the answer, 2, 8, and 5. Except the next number rounds 5 up to 6, so we get 2.86 feet. Here's another. How many nickels are there in $42.25? Now, this is actually a unit and is typically written at the end of the number, but we traditionally put dollars in front of the number for whatever reason. So it's actually not saying $42.25, it's $42.25, which is, we wouldn't do that with anything else. Okay, so we're given $42.25, and then we go out and spend it. No, okay. Yeah, we're given it, but we're not going to spend it. We're going to convert it into nickels because apparently we got a parking fine and we're mad and we're going to go convert this into nickels so we can pay it in nickels. And I got to tell you, I tried that once when I was just out of college and I had parked too close to a fire hydrant. Don't do that, all right? Because then your car's in the way, and if there's a fire, then the fire department can't get in because your car's right there. Well, my car wasn't right on top of the fire hydrant. There was a car parked right next to the fire hydrant, but I got the ticket. And I was furious. It's like, why didn't the other guy get the ticket? Not thinking, well, they probably pulled into that spot after I got the ticket. So I got everything together in nickels. And when I got there, I handed them the nickels and they said, nope, you count it out. Oh, man. So I was there for like an extra 10 minutes counting out enough nickels. Now, how many nickels would that be? Well, let's see. There are how many nickels in a dollar? Well, a nickel is 5 cents. So there are 20 nickels in a dollar. Not $20 in a nickel, although that would be really cool if you had a nickel that was worth $20. All right. But those are usually like old and rare stuff. So unless you're a numismatist, which is what you actually call somebody who collects coins, there's just going to be $20. I almost did it again. 20 nickels in a dollar. Okay. So we have $42.25. We write the given first. We always write the given first. And then we write our conversion factor. Now, this time, the unit we're trying to cancel out is in the denominator. So if it's in the denominator, divide. No. Multiply. Oh, yeah. That's right. Because in the numerator, in the denominator, boom, multiply. Dollars will cancel and we'll multiply and we'll be left with nickels. Right. Because if dividing, then that would be like $2 or 2 nickels. And like 2 nickels is not $42. So doing a division wouldn't make any sense at all. Aha. So multiplying it out, we get 845 nickels. Now, in the real world, if your fine is 845 nickels, you pay 845 nickels. But because this is science and we have to do significant figures, again, conversion factor is not a measurement, so sig figs don't apply. We have 4 significant figures, so we have to have 4 significant figures when we're done. So make sure that you give them exactly 845 nickels right down to the 10th place. So this is easy, right? A lot of your math this year is going to be based on this, where you might have to convert grams to moles or moles to liters or number of molecules to moles, or moles is going to be the thing you're going to have to convert to the most. But a lot of the math is going to involve this kind of conversion, and it's not hard. Now, in the United States, we don't typically use the metric system for everything. Pretty much everywhere else in the world does. So we are learning in 11th grade, 10th grade, whatever, how to use a system that kids all over the rest of the world already know naturally, well before they ever hit high school. So let's do that. Metric conversions. Now, to make it easy, there's a reference table for this. Reference table C. I'm going to want you to add something to reference table C. And by the way, this is only in New York State. If you're watching this and you're not in New York State, then if your state happens to have state reference tables, then whatever that reference table would happen to be. I'd like you to add this to the reference table. In between 10 to the third and 10 to the negative first, I'd like you to add 10 to the 0th. You might just have to, like fit it in there. 10 to the 0th has a prefix, no prefix. That would be like meters, liters, grams, no prefix, just a whole number of unit and no symbol. So meter without anything in front of it, or liter without anything in front of it, or gram without anything in front of it. So if you have 1,000 grams, you have a kilogram. If you have just 1 gram, that's a gram. If you have 1/10 of a gram, that's a decigram. 100th of a gram is a centigram. 1,000th of a gram is a milligram. A millionth of a gram is a microgram. A billionth is a nanogram, nanogram, and a trillionth is a picogram. To give you an idea of scale, let's use meters. A kilometer is a little less than half a mile. No, it's a little more than half. Wait, 1.6? Yeah, a little more than half a mile is a kilometer, right? So that's, a kilometer. You might run like a 5K race, which is 5 kilometers, about 3 miles. A meter is a little more than 3 feet long. Right? You can measure your height in kilometers. Decimeters, that would be about 4 inches in length. That's 1/10 of a meter, right? 4 inches. So maybe like, I don't know, you ball up a fist, maybe the diameter of a fist if you have a big fist. Yeah. Centimeters. This is smaller than an inch. In fact, about the width of your smallest finger. If you're a guy, or maybe one of your like middle-sized fingers if you're a girl, because men and women on average tend to have different sized hands. Not, across the board, but on average. Now, we're going to get into some small stuff. Millimeter. You can see a millimeter. A millimeter is the distance between the 2 smallest lines on a ruler. So if you look at a metric ruler, you got those 2 tiny little lines, the distance between those, that's a millimeter, right? Like the width of a grain of rice would be about a millimeter. Now you're getting into micrometers. Now, micrometers, things that exist on the micrometer scale, can be viewed using a microscope. So you're talking about cells, bacteria, stuff like that, right? Will be in the micrometer range. Now, go down by another factor of 3 factors of 10, and you get to a billionth nanometer. The sizes of atoms are measured in nanometers. Nanometers is about the size of an atom. So if you go another 3 factors of 10 picometers, now you're talking about the sizes of the individual particles that make up the atom, like the protons and the neutrons and the electrons. Those would be measured in the picometer range. All right, that would be about the size. So that gives you an idea of how wide a scale we're dealing with here. So the metric system uses these prefixes so that we can keep the base unit, but talk about like multiples of that unit. So 45,000 grams would be 45 kilograms, and 32 thousandths of a gram would be 32, milligrams. Let's get that back here. Milligrams. Okay. So how do we create metric conversion factors? Well, all you have to do is find out the difference in power of 10 between your prefixes. So if you want to go from kilo to deci, that's 4 powers of 10. And 4 powers of 10 is 10,000. And let's say you want to go from centi to nano, -2, -9, that's 7 powers of 10 difference. So that's a 1 followed by 7 zeros. So it's not that complicated. So how many centimeters are there in 45.2 kilometers? So again, we write down the given, which is 45.2 kilometers. Our target is centimeters. And then we have to create a conversion factor. So centi is 10 to the negative second, and kilo is 10 to the negative third. And we look at those two numbers, and -2 and 3 are 5 apart on a number line. So that's 5 powers of 10. So that would be 10 to the 5th difference, which means that would be 100,000. And once again, we put the smaller unit over the larger unit. The bigger unit, which would be this, kilo, is heavier and sinks to the bottom. And the smaller unit, centi, is smaller and lighter and rises to the top. So there's 100,000 tiny little centimeters in one great big kilometer. And then we would use that to solve the problem, but we'll do that one next. Here's another metric conversion factor. How many nanometers in 18.9 meters? So once again, we identify the given and the target. And then we write down their conversion factors. Nano is 10 to the negative 9. Meter has no prefix. Don't be fooled into thinking it's this, all right? M stands for meters if there's nothing else in front of it. And that would mean 10 to the 0th. There's no prefix, so there's no power of 10. So negative 9 and 0, that's 9 powers of 10, 10 to the 9th, which is a 1 followed by 9 zeros, which is a billion. So there's a billion nanometers, which remember, that's about the size of an atom, in a meter. And then we would use that conversion factor to solve the problem. Okay, how many decimeters in 2.33 micrometers? So again, we identify the given and the target, the given, the target. We look up their powers of 10. Deci, okay, is 10 to the negative first, right? Micro is 10 to the negative 6. There's 5 powers of 10 difference between them, negative 1 and negative 6. And that's 1 followed by 5 zeros, which is 100,000 of the little unit micrometer in one big decimeter. So how about how many meters in 1.73 kilometers? Well, again, the given and the target. Meters has no prefix, so it's 10 to the 0th. Kilo is 10 to the 3rd. There's 3 powers of 10 difference. That's 1,000. And the smaller unit meter over the larger unit kilometer. So you can see every single time you create a metric conversion factor, you do it exactly the same way. Now, let's put it all together. Let's say a chemical reaction takes 0.000350 seconds. That's really, really fast. How many milliseconds is this? So first, let's put together the conversion factor. So the given is the 0.000350 seconds. The target is milliseconds. And so seconds has no prefix, so it's 10 to the 0th. Milliseconds is 10 to the negative 3rd. That's 3 powers of 10 difference. That would be 1,000 milliseconds per second. So we've created the conversion factor. Okay, now let's use it. Let's take our given, and then we'll take our conversion factor, and now we have to decide whether to multiply or divide. Well, seconds is in the numerator, seconds is in the denominator, so we multiply to cancel out seconds. When we do that, we will get milliseconds. But because our original number had 3 significant figures, we have to make sure our final answer also has 3 significant figures. One more example. A batch of medication has a volume of 2.3 deciliters. How many milliliters is this? And by the way, if you think I'm going too fast, all you have to do is go back and then pause the video and just see how I did it. You can even play it back in slower speed on YouTube. That's pretty cool. Okay, so let's do the conversion factor first. Our given is 2.30 deciliters. Our target is to get it to milliliters. You can see how this might be important if you're preparing medication, if you're a pharmacist, for example. Deci is 10 to the negative first. Milli is 10 to the negative third. That's only 2 powers of 10 difference, which is 100 of the small milliliters per larger deciliter. Now, let's use this conversion factor. Let's take our given number of deciliters and then write our conversion factor. Deciliters is in the numerator, deciliters is in the denominator. So once more, multiply, and that will cancel out deciliters and give you milliliters. However, bigger than 1 with a decimal point, they're all sig figs. 3 sig figs. We show 3 sig figs by putting what right here? That's right, a decimal point. And that way we show there's 3 significant figures. So you can see how everything I've taught you before is now being applied to the things that come after. And that's the way my entire course is set up. Everything you do will be built on as you go further into the course. And being able to do conversions and proper rounding is something that you will have to do the entire course long. And if you ever get into science or take advanced science classes, you'll be doing it the rest of your life. Fortunately, once you get the hang of it, it becomes second nature and you don't even think twice about it. It's like every time you tie your shoelaces, do you think, oh my gosh, does this go here? You don't even think about it. You just tie your shoes. You've gotten to the point where it's automatic. Well, you do this enough and you won't have to think about it. It'll just become a routine for you. If you're a musician, for example, you might have to play scales. Well, you probably don't have to think too hard about playing scales. You've been playing for a while. When you first start, you have to really, okay, how do my fingers go? Is like this, or how, how hard do I blow or whatever. So, eventually, even the most difficult task will become just routine if you do it often enough. Okay, one more example. So we have 9.34 centigrams of potassium chloride. We need it for a reaction. The balance measures in grams. So how do we measure it in grams? So let's do the conversion factor. Our given is 9.34 centigrams, and our target is grams. Centa is 10 to the negative second. Grams, well, there's no prefix, so that's 10 to the 0th. And 10 to the negative second, 10 to the 0th, that's 2 powers of 10 difference, which is 100 of the smaller centigrams per one larger gram. Okay, now that we have a conversion factor, let's make use of it. So we're going to take our given, 9.34 centigrams, and then we'll write our conversion factor. We have centigrams in the numerator. We have centigrams in the numerator. How on earth do we get rid of centigrams? We divide. And by dividing, we cancel out centigrams, and we are left with grams. Now, what about rounding? We start with 3 sig figs. This is a conversion factor, so sig figs don't apply. We have 3 sig figs in our final answer. If this was 9.340, then we'd have to pop a 0 after to make sure it had 4 sig figs as well. And that is how you do conversions, about half of the math you're going to do in here this year. I hope you enjoyed it. Oh, wait. Ho! You get a bonus example. Lucky you. The distance between 2 points is 54.3 kilometers. How many decimeters is this? So first we'll do the conversion factor. So kilo is given. Deci is the target. Kilo is 10 to the third. Deci is 10 to the negative first. 3 and negative 1 is 4 powers of 10 difference. That's 10,000 of the smaller decimeters per larger kilometer. We write down our given. Then we write our conversion factor. Kilometers in the numerator, kilometers in the denominator. To get rid of it, we multiply, and the kilometers will cancel and leave us with decimeters, which is what we're trying to find. To properly round, we start with 3 sig figs, we end with 3 sig figs, so that's fine. If this had been 54.30, then you would just have to put a line over this 0 here to show the fourth significant figure. There we go. Now, is there another here? No, we're all done. So go ahead and do algebra and do conversion. And these are skills that will carry you through not just the rest of this year, but every science class you ever take going forward for the rest of your life. So if you're immortal and you get into science, you'll literally be doing this forever. Thank you very much for joining. I hope you enjoyed, and good luck. Bye.